Hi everyone and welcome back to this exponents and surds lesson. Now in this lesson we are looking at equations with rational exponents. And remember from our previous lessons that we always strive to end up with one term equals one term unless it is a quadratic equation, in which case we write it as a one term equals 0, right? Okay, because that is like a trinomial, we factorize it, then it is one term equals 0, and then we can solve it with the zero product rule. Yes? Okay, we did that in the previous lessons. Now, here the steps for rational exponent equations. The variable is a base, the exponent a rational fraction. Okay, so what is a rational exponent equation? That's when the base is a variable and the exponent is a rational fraction. Look, the base is an exponent, there's a rational fraction. Now, we want one term equals one term. Do this by moving the constant terms to one side, then remember to divide with the coefficient to get rid of it on the variable side, because sometimes the variable has a coefficient and we want to get rid of that coefficient, especially if there's numbers on the other side, right? So a number can always be divided with a number. Sometimes when there is more than one term, we must factorize in some way, and that we learned in the previous lesson. Now, once you did this, remember your steps for rational exponents, because you want the same basis. Then put the base that has a rational exponent in brackets and raise it to the power of the rational exponent's reciprocal. Now I'll go through these steps as we do it, but a reciprocal is basically when we have a fraction and the fraction's reciprocal is when we flip the fraction around, right? So do the same on the other side with the same reciprocal, because what we do on the left side we must do on the right side, and solve for the variable. Now let's see. Here we have one term, and there's nothing else I can do. Now we have the base of x with the rational exponent 3 over 2. So basically, there was no step 1 because it's already one term. There was no step 2, right? Now we go to step 3. Once you did all this, which there wasn't, remember your steps for rational exponents, because you want the same basis, right? So, okay, I go and I rewrite this 27 so that it becomes a prime base, because there is rational exponents in this equation, so I'm going to do it to the 27 anyway, so it's going to be 3 to the power of 3. Okay, great. Then put the base that has a rational exponent in brackets. Okay, this base has a rational exponent. Let's put it in brackets. So there we go. And what then? Raise it to the power of the rational exponent's reciprocal. Now that's the rational exponent. We're going to raise this whole thing with that exponent's reciprocal, which will be 2 over 3, because it's just a fraction swapped around. And then we do the same on the other side. So on that side, we're also going to put this in brackets, and we're going to raise it to the same reciprocal, okay? Because what we do on this side, we must do on that side. Not that exponent's reciprocal, the rational exponent, because we're trying to get rid of the rational exponent. This will give me x to the power of 1, and this will equal 2. And if we take 3 times 2 over 3, it will just give me a 2. So we have 3 to the power of 2, and x equals 9. Okay, so when x equals a 9 to the power of 3 over 2, it will equal to 27. Now, let's look at this example and we follow the same steps. Well, we have one term equals one term, so step 1, check. Step 2, do this by moving the constant terms. Well, there's no constant terms, and remember to divide with the coefficient. Now the x variable here is a base letter and it has a coefficient 3. We can get rid of that 3 because there's just a number. So we have x to the power of minus 2 over 3 equals, and then 27 divided by 3. And then we get the following. X to the power of minus 2 over 3 equals 9, okay? And now we want to follow our rational exponent steps. So there's a rational exponent in this whole equation, so we're going to rewrite that 9. So this is going to become x to the power of minus 2 over 3 equals 3 to the power of 2. Then step 3, said we keep on following the rational exponent laws, then put the base that has a rational exponent in brackets and raise it to the power of the rational exponent's reciprocal. Okay, this one has a rational exponent and we put it in brackets and we raise it to its reciprocal, which will be minus 3 over 2. And we do exactly the same on the other side. So minus 3 over 2. And then we just multiply those out. And then we have x equals 1 because a minus 2 over 3 times a minus 3 over 2 is a 1. And then 3, we write that 3 and we take the exponent, which is a 2, and we multiply it with minus 3 over 2, and that gives me a minus 3, right? Okay, wonderful. And this leads to x equals 1 over 27, and we're done. Now, I just want to draw your attention to the following words here. If we have a variable with a rational exponent and a is an odd number, okay? So that a is odd. There is only one answer for x. Look, a is odd, there's only one answer for x. But if we get to an example like this, if a is even, like there is an even number, there are two solutions for x, okay, which will be the positive and negative of this number. So basically we will also have, we can write here, and it will also be minus 1 over 27. And so please don't forget these little rules here. If that numerator is a even number, you will end up with two answers, basically the positive and the negative of the answer that you calculated. Let's go try some more examples. Now here are some examples for you to try. Give them a go. Once you are ready, resume the video and see if you are correct. Here I go. So here we have an equation, and in this equation we have a rational exponent. So just make sure that we have one term equal one term, because we're busy with an equation that has an exponent, right? Whether it's rational or just a normal exponent, we want one term equal to one term, and yes we do. Why do we want that? Because here the base is an x, and that means if we can make the exponents the same on either side, the bases will be the same. Okay, so the first step is to write that 125 into its prime basis. So we have x and 3 over 2 equals, and 125 is 5 to the power of 3, right? Okay, great. Now, the exponents are not the same, so we cannot say x is equal to 5. So we want to get rid of this rational exponent. So we know how to do that. We put this entire term in brackets, and then we're going to raise this term to that exponent's reciprocal, which is just that exponent turned around, right? So we are going to have 2 over 3 there, and we do exactly the same on the other side, because what we do on the one side, we need to do on the other side, right? Okay, great. Now, when we multiply those exponents like this, that 3 over 2 times 2 over 3, we are going to get an exponent 1 there. So it's x to the power of 1, and I'm not going to write that 1. We don't have to. Equals. And then we will write the 5, and then we are going to take the 3 times 2 over 3, which will be to the power of 2. And then in the end, we have x equals, and then 5 to the power of 2 will be 25, and we are done. Excellent. Now, also go and check that rational exponent has an uneven number there, so we will only have one answer, right? Now, let's try the following one. Again, one term equals one term. Great. Because we have an exponent, we would really like to write this side so it also has an exponent and see if the exponents are the same. So let's do that. So I'm going to write here that it's x to the power of 2 over 3 equals, and then a 64, we can write the 64 in terms of its prime base. So 64 prime base will be 2 to the power of 6. I just had to make sure there. So 2 to the power of 6. And then we can see that the bases cannot be the same because the exponents are not equal, and we have a rational exponent. So we are going to raise this side to the reciprocal of this exponent so that we can have x to the power of 1. And what is the reciprocal of 2 over 3? It will be 3 over 2, right? Okay, and what we do that side, we want to do exactly the same on the other side. There we go. And then this exponent times that exponent will give me 1. So I've got x to the power of 1. And that equals, I don't have to write that 1, but this time I did it just to show you. And that is equal to, and we're going to write the 2, and then we're going to multiply the 6 with 3 over 2. And that gives me 9. Okay, so then x will equal to 2 to the power of 9, and that will be equal to 512, I think. Yes, that's 512. There we go. So that's the answer. But now, if we go and look at that rational exponent, the numerator is an even number. So this answer will be 2 answers actually for x. So we have 512, or it will be minus 512, and you are done. Okay, brilliant. And you can go and test that answer to see if you are correct. Now, here we go. In this example, we have 1, 2, 3 terms on this side and a term on that side. So that's not good for equations because we want one term, right? Now we cannot subtract because they're not the same. There's nothing here. We can do no other simplification. We can take that constant to the other side, and then that will become a 3 on that side. But then what about those two? So let's quickly look at the exponents. That is a half, that is a quarter. So do you agree with me that x to the power of a quarter is half of x to the power of a half? And you can test that by taking this half and dividing it by 2, and you'll see it gives you a quarter. So this is a trinomial, and we are going to have to factorize because we want one term equal to one term, right? So let's just quickly rewrite this in trinomial form. So we have x to the power of a half minus 2x to the power of a quarter. And then if we want to make use of a trinomial, we want to make it equal to 0. So this 1 has to come to this side. It will become a minus 1. And minus 2 minus 1 will become a minus 3. And then it will be equal to 0. Okay, great. It's in trinomial form. Now I'm going to take the x to the power of a quarter, and I'm going to make that x to the power of a quarter equal to k. Okay, now we have x to the power of a quarter equal to k, and then x to the power of a half will then be k squared. Now if you are not sure, I'll show you here at the bottom what that means, because, and I'll show you here in blue, because x to the power of a half is exactly the same as x to the power of a quarter times x to the power of a quarter. How do I know? Because when we multiply right the x, a quarter plus a quarter gives me a half, okay? And you can test that as well. If you're unsure, you can use your calculator, because a quarter plus a quarter does give me a half. Okay, brilliant. So then we just said here at the top that x to the power of a quarter equals k, and there we have x to the power of a quarter times x to the power of a quarter, so k times k gives me k squared. Okay, you agree with me? Wonderful. And then we have minus 2k minus 3 equals 0, and then we simply drew the trinomial. Now that will look like this. Again, I'll show you here at the bottom. So we have k squared, and then we write the 3, and then we simply write the factors of these two underneath one another. So k squared will be k and k. Let me just extend that line. And the factors of 3 will be 3 and 1, right? And let's close the block, and this one we extend a bit. Now, this is how I teach the trinomial. If you are interested, go to the factorization lessons and go have a look. I did this in detail in the grade 9 lessons. And now, so we are going to multiply these two, and then if I cross multiply k with 3, I get 3k, And if I cross multiply k with 1, I get 1k. And then what do I have to get with this 3k and 1k? I have to get minus 2k. And to get minus 2k, this 3 needs to be a minus. You agree with me? And I'll write it there in green, a minus, and the 1k needs to be a plus. Because a minus 3k plus 1k gives me minus 2k. And I'll write it here on the bottom. So the answer will be minus 2k. So the two middle terms gives me that real middle term there, right? Now, also a minus times a plus gives me this last minus, because a minus times a plus is a minus. Okay, and then we carry over that minus sign. We carry that minus sign to in front of this 3. And we also take this plus and put it in front of this 1. Okay, so let's do that. So that plus goes in front of this 1 and we have a plus 1 there. Then we have our two brackets. The top ones go into brackets and the bottom ones go into brackets. There we go. So that will be our two brackets, the k minus 3 and k plus 1. So let's write that down here. So we have k minus 3 and as well as k plus 1 equals 0. So that means we have a zero product rule. So either this bracket will be equal to 0 or that one. And I'm just going to quickly do this. So k equals a 3 or k equals a minus 1, right? Okay, wonderful. Because if k minus 3 equals 0, we take the minus 3 to the other side, it will be a 3. If k plus 1 equals 0, we take the 1 to the other side, it becomes minus 1. Yes, you remember the zero product rule. And now we just substitute this x to the power of a quarter into k's place because k is that. So then we have x to the power of a quarter equals 3. Therefore, we can say that we are going to raise this side to the power of 4 because that is the reciprocal, right? 4 over 1. And we do exactly the same on the other side, raise it to 4 over 1. And then a quarter times 4 over 1 is 1. So we have x equals, and 3 to the power of 4 is 81. Great. Now, how about this other side? So we will write or, then what is k? K is equal to x to the power of a quarter. So x to the power of a quarter is equal to minus 1. So let's write that. X to the power of a quarter equals minus 1. And that cannot be. We cannot get a value for x that will be equal to minus 1. So we will write here for this one, there is no solution. Okay, great. So we only have one value for x, and if you put that value in x's place, that equation will equate. So I hope you could follow, and always remember, go and test your answers here, but that one is quite obvious. Let me quickly show you over here that if we take x to the power of a quarter, we can rewrite it as x to the power of 1 and the fourth root of that, right, is equal to minus 1. And you remember this from surds. So now we can never get the fourth root of a number to give us a negative number. That is impossible. Therefore, x has no solution. Okay, and now just for interesting sake, because I changed this to a surd, I'm going to quickly show you how we can solve that problem with surds. Okay, so I'm going to draw a quick line here just to separate these two questions, and I'll draw it there, and then I'm going to do exactly the same one with surds, and maybe that is a bit easier for you. So we have x to the power of 2 over 3 equals 64, right? Now we can rewrite this rational exponent so that it looks like this. It will be the x to the power of 2 and it will be the cube root equals. And then we rewrite 64 into its prime basis, and that will be 2 to the power of 6. Now, what do we do now? Because we have the cube root here, I'm going to put this into brackets and I'm going to raise it to the power of 3 to get rid of the cube root. But what I do this side, I have to do on that side. So this goes into brackets to the power of 3. And then what is left on this side, because 3 divided by that 3 is 1. So I've got x to the power of 2 equals 2 to the power of 6 times 3, which will be 18. And then to get rid of that 2, I'm going to get the square root of this x to the power of 2. And then I'm going to get the square root of that one. So basically this will be x, because it will be that 2 divided by that 2 is 1, and this equals 2. And then I'm going to write this base, which is 2, and it will be 18 divided by 2, which is 9. So 2 to the power of 9, which equals, and remember when we get the square root of a number, it's either the plus or minus of that number. So that equals to 512 or negative 512. And that is quite easy, isn't it? So there's 2 ways to do it, and I hope you could follow throughout this lesson, and hope to see you soon. Bye. This is your host Richard T, and thank you for joining us. Please visit our website mathsa.co.za for free guided exam tutorials.